So welcome everybody to the second part of the solvation of the question number 5 of the Harvard MIT Maths tournament, which was held in spring 2021. In the first part we have solved a part of this question and the various information which we have got from the first part for the corresponding question 5, which has been highlighted here in black box, is been given in this green box, means the information that we have already extracted by the solution of this question in part 1 is basically given in this green box. These are the information which we had extracted, and now we will basically going to proceed further, or we will going to continue. So our main aim is to calculate the value of x1 x2 plus y1 y2 plus z1 z2 whole square. This is basically our main purpose. This is actually our main purpose which we need to evaluate. Main purpose of problem. This is our main purpose of problem about which we need to basically highlight and indicate any speculations here. Now proceeding further, now we all know from the information which is basically being given to us that we can basically write x1 as k cos a, and we can basically write x2 as k sin a. So we can write x1 x2 as k square cos a sin a, plus we all know that y1 can be expressed as k cos b and y2 can be expressed as k sin b. So y1 multiplied with y2 can be written as k square into cos b into sin b, plus now z1 and z2 are individually represented as k cos c and k sin c. So z1 into z2 can be represented as k square cos c into sin c, and the whole square is basically the thing of which we need to basically need to work on. Okay. Now here we can see that we can have the k square common here. We can have cos a, this is the curly bracket, cos a sin a plus cos b sin b plus cos c sin c here. We can take the square of it, and we also need to take the square of this also, so it will going to become like k4. And we all know that cos a sin a can be written as sine of 2a divided by 2 plus sine of 2b divided by 2 plus sine of 2c divided by 2 whole square. Or in other words, we can write it as k to the power of 4 divided by 4 into sine of 2a plus sine of 2b plus sine of 2c to the whole square in this case, which we need to take into our consideration. Now as per the information which we had extracted, that k square is equals to 2, so it's obvious that k4 will be equal to 4, or k4 divided by 4 is equals to 1. So this expression can also be written as sine of 2a divided plus sine of 2b plus sine of 2c whole square. So up till the investigation, what we have found that we actually need to evaluate this expression. Okay, we had gone from here to here, and we have found out that we need to actually evaluate this expression. We need to actually evaluate this expression right here. This is our main concern for this problem. So rubbing all the things and writing only the important things, because we do not have infinite space for solving the question here in whiteboard. We have restricted boundaries. I hope you understand. So evaluation of sine to a plus sine to b plus sine to c whole square. This is the actual thing which we need to evaluate basically. Now the real challenge will going to start. This is the challenge which is awaiting us for a long time and which we need to fulfill here, because this is the hard part of this question here, which we need to carefully solve and analyze basically. First of all, let me have one marker. We need to have a proper evaluation of this function. Now, moving ahead. Moving ahead in this expression, we all know from this expression that cos of A plus cos of B plus cos of C is actually negative of root 3 divided by 2 times of root 2, because we can see from this expression that cos A plus cos B plus cos C is equals to negative of root 3 by 2k, where k square is equals to 2, so k will be equal to root 2, and cos A plus cos B plus cos C will be equal to negative of root 3 by 2 root 2. We are only going to take the positive value of k because k is representing the magnitude, and magnitude is always positive. Similarly, we all know that sine of A plus sine of B plus sine of C is actually negative of 5 divided by root 2. Now if we add them, let us suppose that we add them, we actually need to evaluate this and we need to take this into our consideration, that we need to evaluate this. Now if we add these two expressions here, we will going to get cos A plus sine A plus cos B plus sine B plus bracket cos C plus sine C, and it is and they are basically equal to negative of root 3, negative of 2 root 5 divided by 2 root 2. ठीक है? Okay. Now this needs to be taken into your consideration. Now what I will going to do, I will basically going to put all this thing and this thing under a bracket, and we're going to square this function. Okay, I'm going to square it, and we all know that a plus b plus c whole square is equals to a square plus b square plus c square plus twice of ab plus bc plus ca. So I will going to just expand this thing. So it will going to be cos a plus cos b whole square plus cos a plus sine a, cos a plus sine a, cos b plus sine b whole square plus cos c plus sine c whole square plus twice of cos a plus sine a into cos b plus sine b plus 2 times of cos b plus sine b plus cos c plus sine c plus 2 times of cos a plus sine a cos c plus sine c is equals to square root of 3 plus 2 times of root 5 divided by 2 root 2 and the whole square of this fucking expression. It is our main thing. Okay. Whew. Moving ahead. Now we need to break the individual squares which I had represented in parentheses here. Okay. So cos a plus sine a whole square will be equal to cos square a plus sine square a plus 2 cos a sine a. It is eventually 1 plus sine of 2a. Similarly, cos b plus sine b whole square is 1 plus sine 2b. Similarly, cos c plus sine c whole square is equals to 1 plus sine 2c. And if we dig deep here, if we take 2 common, here cos A plus sin A into cos B plus sin B is actually representing cos A minus B plus sin A plus B, because cos A cos B plus sin A sin B is actually representing cos A minus B, and the rest of the term is basically representing sin of A plus B. Plus the second bracket will be reflecting cos of B minus C plus sine of B plus C, and the third bracket is basically representing cos of C minus A plus sine of C plus A in this expression. Okay, so this whole thing will be equal to root 3 plus twice of root 5 divided by 2 root 2 whole square. Okay, this thing needs to be clear inside your fucking mind, then only I can proceed ahead. Now I need to take into your utmost consideration that here we can basically have a proper representation. Okay, we also need to have a proper representation basically. We actually need to evaluate this whole expression out. So this thing also need to be kept in mind. So yeah, this is done. This thing also needs to be keep in mind here. Okay, so I need to write this expression down, because this expression will also be in use in our proceeding things. This is a complicated question, that's why I'm telling you. And the board length of actual solvation is also going down. Now we also need to take this that sine 2a plus sine 2b plus sine 2c is being considered p. Okay, sine 2a plus sine 2b plus sine 2c, if we were going to consider this as p, we can shorten this equation as 3 plus p plus 2 times of cos of A minus B plus cos of B minus C plus cos of C minus A plus sine of A plus B plus sine of B plus C plus sine of C plus A. This whole thing is equal to root 3 plus 2 times of root 5 divided by 2 root 2 ka whole fucking square. And now this thing is actually going more and more tough, and it is actually complex, means that is a problem with such trigonometric orientated questions, that they tend to be difficult, and they eventually are also. So this is also an important thing, so I'm highlighting this on. Moving further, we know that cos A plus cos B plus cos c is equals to negative of root 3 divided by 2 root 2. Okay, we also know that sine a plus sine b plus sine c is equals to negative of root 5 divided by k, where k is basically a root 2. We also need to take this into our consideration here. Now what we're going to do is we're going to square the both sides. And put an add sign in between them, and the things will going to turn out as cos square a plus cos square b plus cos square c plus 2 times of cos a cos b plus 2 times of cos b cos c plus 2 times of cos c cos a. So cos square a plus sin square a is 1 plus cos square b plus sin square b is 1 plus cos square c plus sin square c is 1 plus 2 times of cos a cos b plus sin a sin b is actually 2 times of cos of a minus b plus 2 times of cos b cos c and 2 times of sin b sin a. When they will be added together, they will going to make 2 times of cos of b minus c, and when 2 times of cos c cos a and 2 times of sin a and sin c will be added together, they will basically going to make 2 times of cos of c minus a, and this whole expression is basically equal to 3 divided by 4 into 2 plus 5 by 2. It is like 3 plus 2 times of cos a minus b plus cos b minus c plus cos c minus a in this whole expression basically. So cos a minus b plus cos b minus c plus cos c minus a is in this case represented as 23 by 8. So cos of a minus b plus cos of b minus c plus cos of c minus a will going to be represented as negative 1 by 16. So this is also a very important thing. Okay, so when we will going to take this result along with this result and put them together and produce and try to produce a result, what eventually we will be ended up is that 3 plus p plus 2 times of negative 1 by 16 plus sine of a plus b plus sine of b plus c plus sine of c plus a. This whole thing is actually equal to root 3 plus 2 times of root 5 divided by 2 root 2 whole square, or it can also be written as 3 plus p plus 2 times. Now what if I consider this symbol, the symbol of a triangle representing a plus b plus c? If the symbol of triangle is representing a plus b plus c, then the above expression will be written as 3 plus p plus 2 into negative 1 by 16 plus summation of sine of triangle minus q, where q is first a, b and c. They are actually equal to negative root 3 plus 2 times of root 5 divided by 2 root 2 whole square in this expression basically. So here we need to find the value of p, so we need to be careful here. we can have 3 plus p plus 2 times of negative 1 by 16 plus sine phi cos a minus cos triangle sine a sine triangle cos b minus cos triangle sine b sine triangle cos c minus cos triangle sine c. This whole thing or this whole shit is actually equals to root 3 plus 2 times of root 5 divided by 2 root 2, and this thing will be equal to this. Now we have 3 plus p plus 2 times the negative 1 by 16. Here we have sine triangle common, and the value of the sine triangle is root 5 by k cube, as we can see from this expression that it will be equal to root 5 divided by k cube, where k cube is 2 root 2, and this is actually multiplied with cos a plus cos b plus cos c, which is actually negative root 3 divided by 2k or 2 root 2, minus we are having cos triangle here as common, where value of the cos triangle, as triangle is representing a plus b plus c, is root 3 divided by k cube. Here k is representing root 2, so root 2 to the power of 3 is 2 root 2 multiplied with sine a plus sine b plus sine c. It is equals to negative of root 5 by k. So negative of root 5 by k. This thing is equals to root 3 plus 2 root 5 divided by 2 root 2 whole square. I hope you can see now we finally have arrived at that phase where now I can say, now I can figure it out through equation. This is that thing for which I was doing the mathematical shit. You can see this is that fucking shit. यही तो चाहिए था सारा. Now we will basically going to proceed ahead with this expression. Now let us rub this thing out. I hope you can understand this whole thing here. So writing this thing here, we will basically going to get 3 plus, we can see here a p, where we need to evaluate p square here, plus twice of negative 1 by 16 minus of root 15 divided by 8 plus root 15 divided by, oh, this is actually root 2, this is k, so this is root 2. 2 root 2 into root 2 is equal to 4. Okay, and this thing is equal to root 3 plus 2 times of root 5 divided by 2 root 2. Okay, so this is actually 3 plus p plus 2. This is negative 1, negative 2 root 15 plus 4 root 15 divided by 16. It is equal to root 3 plus 2 root 5, or if I write it in simple and clear way, or an expression, it is like 3 plus 4 times of 5 is 20 plus 2 times of 2 is 4 into root 15 divided by 4 into 2, 8. This expression can simply be turned as 3 plus p plus 2 2 root 15 negative 1 by 8, which is equals to 23 plus 4 times of root 15 by 8. Moving ahead, it is like 3 plus p negative 1 by 8 plus root 15 by 4. It is like 23 by 8 plus root 15 by 2. Or making thing as clear as possible for us, we will just going to shift the denominators, like 23 plus 4 root 15 minus 2 root 15 plus 1 by 8 is that 3 plus p is equal to like 24 plus 2 times of root 15 by 8, where 3 plus p is equals to 3 plus root 15 by 4. 3 and 3 will be cancelled. P is root 15 by 4, and our mission is to evaluate from here the value p square, and p is root 15 by 4. So the value of here of p square will going to be 15 divided by 16. So this is equal to 15 by 16, which is the answer for this whole question. That was it. Yeah, this was actually a very pretty difficult question in terms of all the variances and preferences and expansion and ideology of mathematical expressions and series which it has used. So yeah, it was a all-in-one complex number question, trigonometry question, algebraic question, and expressional question. So this question was a question which you can say that yeah, it has met the level of what you say Harvard and MIT, but still not as much as IIT. But okay. See you in my next videos regarding mathematics. Bye.